Yes.
All right, fantastic. Well, thanks for introducing me, Umair, and setting this whole thing up. Peter and Ryan are tough acts to follow, I think, but I think this presentation is in the same vein because I'm all about making SPIFFE easier to use and and better for everyone. So I really liked Peter's title as a SPIFFE enthusiast because that also describes me perfectly. I've been working in the space for quite a while. I've helped a lot of companies deploy SPIFFE Inspire, and I'm always working on making it easier. So the company I'm working with now is I'm working on a project with a large telecom company that has hundreds of databases and tens of thousands of database users, almost 100,000 database users. And we're working on getting that all into a SPIFFE environment. So that's just the background for where I'm coming from. The other things I do, I host SIG Spire every 2 weeks, and I always announce that on the Slack. So please join if you can. It's at 12:30 my time, 10:30 Pacific. So please join SIG Spire. We always have interesting presentations and status updates on the project every 2 weeks. I'm also on the steering committee, and I'm coordinating this steering committee election. So if you haven't voted for the SPIFFE steering committee, please vote now. Today's the last day. Just you should get an email. If you don't have an email, message me on Slack, and I'll make sure you get an email. And now for the presentation. So we'll be talking about SPIFFE Link, which is a batteries included SPIFFE helper, which for those familiar with SPIFFE helper, I think that's a pretty good slogan that explains what it does. And if you're not familiar with SPIFFE helper, then you'll have to watch the presentation and find out more. So first, a little bit of a disclaimer. Everything I'm talking about here is open source, but it's not quite ready for production. It's just in my personal GitHub. I would love to contribute this upstream once it's a little more mature. And the other thing is we're working on a bunch of other stuff at Sentima. This is just one project out of several, so I don't want to set the standard that all we're doing is this one project. This is actually one piece of a larger puzzle we're fitting together that we can talk about, but not in this presentation. So this is the agenda for the presentation. We're going to talk a little about just how to use SPIFFE identities in general, then the SPIFFE helper approach, what we're doing with SPIFFE Link, the current progress, and then I can do a quick demo. So how do we use SPIFFE identities today? So SPIFFE creates identities. How do you use them? Well, first of all, you can use the workload API directly, and this is ideal because then you get all the information. You get all the federation relationships, you get everything you need to use that identity. You get JOTs, you get X509 certificates, you get any other token we come up with in the future, because this is SPIFFE's native way to get identity. Unfortunately, if you're using off-the-shelf software or even open source software like Postgres or MySQL, you can't easily do that because you'd have to change the code. And right now, our library support is really good for Go and for Java. For other languages like Python and C, there are libraries. They're a lot less mature and they're a little harder to use. There's also a Rust library that's in progress. Really, if you're going outside Java or Go, using the workload API is kind of tough right now. Hopefully no one disagrees with me about that. I don't know what other languages people are using, but if you're using .NET or Ruby or some other language, it's going to be an uphill battle to use the workload API directly. So then how do you solve that problem? Well, one is you can use a proxy. So proxies are great for Kubernetes. Kubernetes has really amazing support for proxies. You can set up a sidecar very easily that then proxies all your traffic. There's even these things called service meshes that proxy all the traffic for you, and they install automatically, they run automatically. This works really well for HTTP or HTTPS because proxies understand those protocols. They can read the protocol, they can make authorization decisions based on the headers in HTTP. Typically, they can't parse other protocols. And this is a bit of a controversial statement because Envoy does have a bunch of plugins for parsing other protocols. The support is really limited. So you might get just enough to do like an HA load balancer for Postgres, but you might not get enough to make authorization decisions for Postgres. And then once you get outside of open source, if you're trying to do a proxy for Oracle, you're just completely on your own. There's nothing that supports that. So the proxy approach is probably the most common way to use SPIFFE identities today, most of the people I work with are using a proxy approach in some way because they're in Kubernetes. It's easy to deploy. But it has this downside that it really doesn't work that well for protocols once you get outside of HTTP. OIDC approach, this is for federating with clouds. If you're using RDS as your database, this is fantastic because RDS is an Amazon product. It supports Amazon identities. You can federate with AWS Cloud and be able to use JOTs to log in seamlessly to your AWS RDS instance. Obviously, if you're not in the cloud, that doesn't work. Serverless, I just put this on here for completeness. We do have serverless support using SVID stores. So you can push the SVID to a location like an S3 bucket, some kind of SVID store that will store it and then only grant access to the right people. But that's really intended for serverless functions, maybe ECS, but it's not going to work for very much outside the cloud environment. And SPIFFE Helper is kind of the grab bag for everything else. So SPIFFE Helper sits there, and what SPIFFE Helper does is it pulls workload identities, it takes them, it saves them to a file, and then it signals your application to ingest those identities. And that's what we're going to be talking about today, is SPIFFE Helper and how we can improve it. So first of all, I can pause here and answer any questions that are coming up. All right, I'll keep going. We can have questions at the end. So the idea of the helper approach, like I said, you've got a Spire server, of course, you've got an agent. Theoretically, this could be some implementation other than Spire, but right now it's Spire. And then you've got the SPIFFE helper that's getting certificates and private keys. It's saving them to disk, and then it's somehow signaling your database to ingest those certificates and private keys. How does this, and when I say database here, I'm being very generous with database. This means some kind of application that uses X509 authentication, which is most commonly a database, but it could be Kafka, it could be Redis, it could be something I haven't thought of, some kind of distributed cache or queue. These are really, really common in customer environments. So then, of course, you need to have some kind of workload that's talking to the database. Obviously, that's going to get a SPIFFE identity as well, maybe through some other path. It gets that SPIFFE identity, and then it can talk to your database. Because the identity is loaded ahead of time by your SPIFFE helper, but you get the root certificate for the environment, and then you get this workload that's logging in with a private key and hopefully signed by the same authority, and the database can make authorization decisions, can assign you a user ID in the database, and then it can match that up with roles that are predefined in the database. So you get all this data about the user that's logging in that corresponds to that workload, and then that's allowing them to access the database with all the permission structure that's allowed in that database, unlike a proxy system where the authorization decision is made by the proxy typically. So this is really ideal for accessing databases. Okay, so let's talk about some pros and cons of this approach. So it works really great to load certificates into something that already has X509 based authentication and authorization. So you could do databases, queues, caches. It's a bit of a speculation, but you could probably get it to work with SSH. You don't have to worry about your application-specific proxies. You don't have to have a custom Envoy configuration that can parse a Postgres protocol. It can just, Postgres is just natively speaking X509 authentication. And Postgres doesn't even know about SPIFFE. It's just getting certificates in, and it knows how to do authentication based on those certificates. But the big question is, how do we deploy this for enterprise environments? So like I said, I'm currently working with a large telecom company. They asked me not to say the name, but it's a very large telecom company that everyone has heard of. And they have a databases team of 20 or 30 people that manages a bunch of different database platforms, hundreds of different databases, over roughly 100,000 database users, something on that order of magnitude. So there are all these database users. They're talking to hundreds of different databases. Some of them are Mongo, SQL Server, Oracle. They use Redis. They use every database platform you've heard of. and different versions of all those platforms as well. And every one of those is a high availability environment because this is a production system. They can't have any of those go down. So often there are multiple instances of each one of those databases. They also use Oracle. If you've ever worked with Oracle, Oracle is like an operating system in itself. It has all its own language. You have to, for example, to use certificate-based authentication in Oracle, you have to give it what they call a wallet, and it has all these commands for manipulating wallets, saving wallets, converting the formats of wallets, and then loading them into the Oracle front-end load balancer. But there can be multiple different front-end load balancers. It's an extremely complicated environment. And again, there are multiple versions of all these databases as well. So what we've found is the SPIFFE Helper approach is the right approach, but the SPIFFE Helper that exists right now is not very helpful for their environment. And another thing is, naturally, if one of these systems fails, if one of these hundreds of databases fails, they need some kind of telemetry that's going to tell them that it failed, so they can fix it. And right now, that's a little bit tricky to implement. What we'd ideally like to do is every single time we rotate a certificate, be able to test that database connection and make sure it really works after the rotation. So that's and this is basically what SPIFFE Helper does today. All it does is it saves some files with a bundle and a certificate, and then it executes a script that you specify in the config file that tells the database how to reload that certificate. So right now, kind of these details of how to do the reload, where to save the files in a way that's accessible to the database, all of that is up to you to figure out. So how do we scale this? How do we make this something that we can deploy in a large enterprise? So we started a project called SPIFFE Link, literally based on the SPIFFE Helper source code as a starting point, but intended to be much easier to use. So it has built-in modules for configuring automatically with popular databases, and it'll, as we grow this project, it'll have the best practice configuration for each one of these. Observability, very important. So every time we rotate a certificate, these database admins want to know in some format that the certificate rotated. So it can upload that data to OpenTelemetry, store in the logs what just happened, and then test that the connection still works after rotating the certificate, which is very important because these are critical databases for a huge company. People would start losing their internet connections, start losing their television if the database went down, and that's happened in the past. So they really need to know that these databases are up all the time. And then remote link. This is something that I think is a little bit controversial as well, but we'd like to be able to manipulate these databases. If you have the database running over here, we'd like to have a VM over here that's getting the certificates and installing them in the database. And the reason for that is essentially database admins are very cautious about installing something alongside their database. Often these are actually prepackaged database appliances that they buy from a vendor. You can Google Oracle engineered systems. They really don't want to be installing a lot of stuff on the database box itself. So if we can manipulate the database, using the database protocol, using the Oracle protocol or the Postgres protocol, use SSH to copy over the certificates, that's way better for them. They don't want to have a ton of complicated stuff running on their database box because they need to keep that box up all the time, no matter what. And they're essentially afraid that it's going to cause problems. So ideal world, this is what our configuration would look like. We should be able to specify some databases with a type, a connection string. This is used for telling the database to reload, and then also for checking the connection, checking that it works after reloading the certificate. SPIFFE ID, because we have multiple different databases, they could be getting different SPIFFE IDs. And you could ask, why not just have multiple copies of the SPIFFE link instead of one copy that is manipulating multiple databases? And that's 100% a deployment thing. These are not cloud native environments. Databases are running on boxes, typically physical bare metal boxes in data centers, and they would much rather just have 1 or 2 or 3 SPIFFE links instead of 1 per database. So what we'd like to do is have this concept of steps in rotating the certificate. So we retrieve the certificate, we check the certificates, check the database configuration that it will actually work with that certificate. When I say check the certificates, a lot of these databases do have custom weird requirements. So they may require a DNS name in the certificate. Another common requirement is certain encryption algorithms. So some Oracle stuff actually still requires RSA and doesn't work with ECC. Or you might have a FIPS environment where there are additional requirements on top of the certificates. Okay, so then we check the database configuration, check that it really will be able to load these certificates, save them to a file, send a reload command. Each one of these steps needs to send metrics and be traceable and also have its own logging. So we want detailed information because if any one of these steps goes wrong, the database potentially goes down. So we need to be really, really careful as we're executing these steps. And these database admins, they're very cautious, very conservative. They really do not want to be implementing something in their platform that's going to cause problems because they're the ones who are going to have to work over the weekend to fix it. So in terms of planned database support, we actually do have demos of this on our website. They're pretty POC demos, a lot of shell scripts involved right now still. But for Postgres, MySQL, MariaDB is essentially the same as MySQL. MongoDB, Microsoft SQL, SQL Server is actually a really interesting case because it only supports Kerberos authentication. So what you can do is you can federate SPIFFE, you can federate Spire to an ADFS server, Active Directory Federation Services server, and then you can use that identity through ADFS to log into MS SQL. We do have a demo of that working. It's a little bit convoluted. We may have to put some more thought into how to make that process easier. Redis, like I said, the customer I'm working with really cares about Redis. So we're going to try to implement Redis. This actually is going to require some new features in Redis, and we're talking to the Redis team about implementing that. It's on the roadmap already, but I don't have any kind of idea when it will be released. And hopefully more databases. There's more databases all the time. You hear about companies using CockroachDB, ScyllaDB, all these other databases are popping up all the time. And we'd like to be able to support a decent subset of the databases that are available and be able to really provide high quality, 100% support for these database platforms. So open questions. I always have an open question slide in my presentations because I don't have all the answers. One thing is, should we package this in with a Spire agent? Typically a database system wouldn't be running a lot of stuff other than databases. So just to make it easy to deploy, can we figure out how to have a captive Spire agent on there? Just using the actual Spire agent binary, but started by SPIFFE Link. I don't have an answer for that question. It might be nice. It might not be so great. I don't know. How do we integrate with OIDC for Microsoft SQL Server support? Like I said, I don't have an answer to that exactly. We can demo that, but right now it's a little bit of a hack with that extra ADFS server that's federating into the OIDC endpoint from Spire. So it's a little bit complicated for that case. How can we integrate with a service mesh or proxy? If you are using a service mesh or proxy, how can we kind of integrate with that approach so that if you have a workload that's running in a service mesh, how can we make sure that it will be able to access that database that is not running in a service mesh? Like I said, some databases have these unusual requirements on top of X509, like RSA only support. And then federation is the big question mark here because the way names are scoped in X509 isn't really compatible with the way they're scoped in SPIFFE. So we have to, if we're federated to a different trust domain, we have to somehow double check and make sure that that incoming identity is really from that foreign trust domain and not from the local trust domain. So X509 has some extensions to try to support this, but no one actually uses those extensions. So potentially, if you're in a federated environment with databases, you could have a security hole there And I don't know how to fix that right now. I think we can figure it out together. You might need another proxy in place that can somehow just do that federation check. I hope that wasn't too in the weeds. That's all explained in a lot of detail in the SPIFFE book. Okay, so try it. This is on my GitHub right now. I can switch to a different window and do like a 10-second demo here. It's not an incredibly impressive demo, but I'll do that at the end. And then just as a thank you, again, this is all based on the existing SPIFFE helper. This is starting with something that already exists. And Faisal, Marcos, and Marcos have put a ton of work into this project over the last several years. So I'm really glad to have that solid foundation to build on. So with that, I'm going to switch over to my terminal window and just do a very quick demo. You always have to have a demo, but it's not an incredibly impressive demo because this is all functionality that already exists. All right. So first, we have these config files. They look like this. I have a dummy database type. All this does is it saves the certificate to disk. It doesn't actually install in a real database. That was just easier for demo purposes. And if I run a shell script here, it's going to start up the, this does take about 30 seconds. It's going to start up Spire. It's going to start up an agent, and then it will be able to show that it's executing the different stages in retrieving a certificate, checking the certificate, saving it to disk. This is all just log output from Spire that it's showing on the screen. So we're able to generate an SVID here. Just wait a second, wait a second. This is actually based on a SPIFFE helper test. So when I say I owe them, I really owe them. Okay, so here it started the task database update. It ran a step in that task, and it completed the task. And then now the task is complete. It's removed from the list of running tasks. Each one of those is traceable with open tracing. Inside OpenTelemetry, we've got some OpenTelemetry configuration here. So you can tell that it's really happening. And with that, my presentation is done. I hope I wasn't too fast or too slow. I wasn't really keeping track of the time. But we probably have a moment for questions.
Hey, Dan, I have a question related to limitations you mentioned for SPIFFE Helper. Like all these limitations specific to database support, like the thing that you implemented in the SPIFFE Link, or like there are some specific other limitations?
No, I wouldn't even call them limitations. I would just say SPIFFE Helper is, it's a very general tool. It just gets certificates and executes shell scripts. The problem is it's up to you to write all the shell script that does everything you want to do. And that's a difficult task for a lot of companies. It's a difficult task for me. So I'd like to have a really standardized version of that that works for each database we need to support. You could write shell scripts or even external programs that integrate with SPIFFE Helper and do all of the same tasks. It's fundamentally the same thing. We're just trying to make it easier. Any more questions?
Quick question. It's about like, it looks like you execute saga pattern for actually go through steps. And do you have some sort of recovery mechanism? Let's say if one step fail, is it like manual work to recover, or you have some automated waste after?
I've put a lot of thought into that, and I don't have a good answer right now. I think that there are a couple of different failure modes in this. One is that something could fail while you're updating the certificate. So say you're trying to load the certificate in to Oracle, and it's a certificate Oracle doesn't like because it's not RSA. So that's one failure mode, but that's a failure mode that we can detect ahead of time. We can hopefully, when we're starting this up, double check that the certificate is the actual right format. So hopefully there shouldn't be too many failures that require a recovery procedure. The biggest failure that could require a recovery procedure is like if SPIFFE Link crashes and it leaves the private key sitting in a file on disk. That's really bad. We need to make sure that when we shut down, we delete any key material. So I don't know. I don't have a good answer for that question, but we will have to have some way to recover from failures when those failures could cause problems in the future.
Can you talk a little bit more about the challenges with Redis and some of the new features that you're working on them with?
Oh, yeah, sure. The problem with Redis is really simple. It does support client TLS authentication, but then after that completes, you still have to do password-based authentication. So the TLS certificate authentication is like just a preview, and then you still have to do traditional password authentication. So we're working with them on that. They understand the problem, and they have it on their roadmap. Because the customer we're working with is a huge Redis customer, they've prioritized that. But it'll probably be the next Redis version or the one after that, something like that.
Great, thank you.
When you get to the final step of the SPIFFE Helper process, where it has to trigger the database itself to reload to pick up on the new stuff, are you finding that that's had any implications for the availability of the database itself? Does some work better than others? And does anyone push back and say, hey, you're going to be restarting my database every 5 minutes or every hour or whatever?
That is a great question. I think every database I've worked with actually handles that correctly. So it doesn't really it doesn't affect existing sessions. It just affects the keys that are accepted for new sessions. I think that's not a bug we've encountered. Although it could be, definitely as we get into more databases. And I'll have to do some more testing around that. I actually don't know the answer. Any more questions?
I have a question.
Mm-hmm.
So when you're working with different databases, do you see the performance becoming a concerning thing for them to adopt TLS? Because some databases might have a more strict performance requirement. Mm-hmm. I remember Redis, they have done some testing in the community. It's probably on an older version. Enabling TLS could cause a 40% reduction in performance.
Yeah. So here's what I've been telling people. I'm not exactly sure if this is that accurate, but definitely when you're talking to database administrators, the first question they have is, will this impact availability, and will this impact performance? So typically, TLS is almost free after session initiation. So if you can figure out how to keep your sessions alive for many transactions, that cost of initiation is amortized over many different transactions, and most of the time that works. There are cases where that doesn't work. Basically, if you have a buggy client that's starting new connection, then it's going to do TLS negotiation, and that can be very costly. And the answer there is either disable TLS for that client or fix the client. But after that session initiation, symmetric encryption is really, really fast. It doesn't really have an impact, assuming you're on somewhat modern hardware. Hopefully that answers the question.
I can add that in a book that we wrote that's on spiffe.io/book, there is I don't remember a specific chapter, but there is a section in a chapter related to added latency for TLS, MTLS, basically. But if everything configured properly, it's not negligible for MTLS. It add in initial latency, but everything else should be fine.
Where can I find that book?
spiffe.io/book.
All right, I posted it in the chat, so everyone who's on Zoom can access that book. All right. Awesome.